Advent of code, day 17. Okay. Do do do. So we have. Are we really re-implementing our encode? Okay. Don't rush. 3-bit number. Okay. What are we trying to do? Showing the values in output in a single string. Okay. Mm-hmm. Okay. Mm-hmm. Jump. Literal operand. So mm-hmm. Combo. Um, okay, I'm gonna need that in there. Okay. Truncated to an integer, right into the A. Oh, is truncated to an integer. Oh, of course. Duh. I'll need that. That just means that. Um, one is VXL. Bitwise or uh, cap. That's what I thought. So that. Oh, why that? Ew. Get rid of all those. Um, do. Quad 8. Nothing. Okay. Quad 8. Wait, what did I do? EXE. Oh, yeah. Then out. Okay. So then we're your C and your B. Okay. Oh, right. Of course. Tuple out of range. Oh, right. And halt. Okay. Uh, yeah. 4, 6, 3, 5, 6, 3, 5, 2, 1, 0. No. Crud. Okay. This he didn't like. Okay. The registers are in order. They are great. B, C. Okay, so C here is 9. We've got 2, comma 6. Set B to 1. Yeah. Um, put 0, 1, 2. Yep. Two, 5, 6, 3, 1, 0. We're gonna have to decompile this, aren't we? Leave 0 in register A. Yes. 29. 1, comma 7. B2. Oh, there we go. There's my. Okay, so what was this? Bitwise or bitwise exclusive or 26. Okay. That was terrible. Yeah, okay. And this is going to require decompilation, right? Um, this is this has to be decompilation. I'm going to, what am I going to do? So I want to brute force. I don't need those anymore. We want Yeah. Do that. Okay. So it's not defined. Yeah. But you, okay. Good. So I've got that. Um, and then all right, don't expect you to actually finish. Okay, you're actually going faster than I want or expected. So we'll print progress slower. Okay, so while that is going, the program itself is actually very simple. Yes. Okay. Out of curiosity, what was 1.5? Yeah. Yeah. I'll back up here. The combo stuff, of course, this combo junk is yuck. Not appear in valid programs. B combo, though, because the program never changes. Program never changes. So, yeah. Yeah. Okay. Mm-hmm. Mm-hmm. Yeah. Okay. Let's copy all this. Yeah. Copy all that. I do need my operand. And of course my opcode, which I forgot. How is that going? Terribly. So we have IP plus equal to, yeah. Yeah. Then this was doing B equals B or brand. Eight. Um, and that's going to be our loop. Then we have B equals B or C. Yeah. And I wonder which register that's going to be. So then these are that, but it's assigned to B, that, but you're assigned to C. Uh, about need this a little easier to parse. Okay, great. Now we work on this on the side, and we keep an eye on you, just in case, but it's never going to finish. So this is our raw output. So this ends up being, right, the raw output's wrong. Is you, wait, um, wait, oops. So two is which? Two is this. Yeah, that would do it. Out.append, yeah. Okay, that's better. Okay, so we have go to label 0, meaning I don't need any of the other labels. Okay, so B is ARM Mender 8. Wait a moment. There we go. Try this again. So label 0, we care about. Everything else we don't. B is that. A only gets updated there, so we can inline this. Interesting. XOR 3. That's very interesting. XOR C. A floor division 2 up to the third. Which should be 8. Just double checking because I'm. So that's just an A shift, and you can in fact be up here. So we have native ARM mod 8 equals. In fact, we'll do A. So we're taking every 3 bits of A from the lower. Wait, sorry. Your ARM. Okay. Then we'll take. Oh. A div, because we don't actually update A until here. We use A again. Okay, fine. Does this even matter? C is the remaining. Wait. This is the same as C equals A shift it by B. So we're taking extra bytes B. I only care about the last 3 of that. Yeah. So actually, is here going to be positive? And we just do that. This is so wonky. I'm glad we didn't have to do this with Intcode. That is my normal program. Let's just double check. It's the expected output. Okay, I did something wrong. Crud. That is why I'm doing that check. Oops. And then I don't need. Yeah. Oh, don't append. Do that. Crud. Wait. I'm sorry. This answer to part one is that. Am I looking at the wrong thing? I think I am. I think this matches. Yeah, that does match. Okay, sorry. This is fine. This is fine. Okay, yeah. So now that's better. So A right shift by B. B is going to be 0 through 7. This is what gets weird. Equals A div, that's fine. So we've taken those 8. Then we are shifting. That is okay. Backtrack. I want this to output a 3. Yeah, this is going to be better if I backtrack, actually. So what I want then is target equals yeah. So I want that's going to call you reverse. Yeah, this will be much easier. And yeah, val equals target dot pop was 0. That means that b equals val is b 3. C is what? B is ARM or 3. This is what's wonky. So at this point, I've got the B that needs to be here. But then I need B or C. Rather, I need C to know what that goes in reverse. I'm really doing this slowly. That's really quite annoying. Let's go forwards. I have code actually here. You do, yeah. I can't do sure. What is binary of this? Right, so we've got this. B is this or 3, which is then going to be a 4. So then we'll shift by 4. We'll take those. We'll then mask that with that, which was 4, which will leave us with then 2, which then leaves us with 1. That all makes sense. So actually, though, initially it doesn't even matter. Because everything to the left is just 0. So actually, let's go all the way over here. We need 3. Um, 9, and we do print out 9 numbers. So this becomes a 3 at the end. Our target value is what? This becomes a 3. This becomes a 3 because this or 3 then becomes 1. And then it masks with itself. That's interesting. That's very interesting. So actually, though, see here, I only care about the last 3 digits, right? Pretty sure I only care about the last 3. Let's double check. Yeah, that's that one, right? Yep. So then I do 8, and you should still be valid. And you are. Okay. So I only care about those 3 bits. So I then need. There's only a few, there's only 8 things I can test every single bit here. So actually, yeah, I am definitely overcomplicating it. What I want then is. Yeah, okay. Yeah, I definitely. Don't go backwards, go forwards. Okay. New A equals A times 8. Um, um, in range 8. New A equals times 8 plus test. So then we have 8. A equals A div. I don't care. B equals B, C. 3. B and 8. Test. Yeah. I don't need that. Don't need any of that. Print A. I need this. Of course. Okay. I'm gonna get, this is probably gonna give me multiple potentials, isn't it? See, ooh. Okay, I'm doing something wrong. New A. Oh, right. That is incorrect. Well, that one actually should be correct. All right, that's better. Okay. Oh, and then this is gonna get really, really big, isn't it? Nope. That. And I can do a smarter search if I need to. So then this is then going to be that. New A. Yes. Okay. Is that the correct one? Okay. It's not. But if I take this, I plop that in there. Great. So now I do this again. Oh, crap. Sure. Let's make sure that doesn't go way too big. That's not bad. I take this to double check my answer. No. Okay. That's why I did 2, 4, 1, 3, 7, 5, 4, 1, 1, 3, 0, 3, 5, 5, 3. But then there's a 0 at the end. Okay. You know what? At least one of these should be good. Are these all wrong? Oh, it's because I'm missing my 0. Or... Okay, that one worked. Okay. Ooh, 119. I was... I feel like I was close. You can die. That was a mess. That is going to take me a while to figure out exactly what I was doing to even explain it. First and foremost, I'm glad to be done. I would have liked to have leaderboarded, but it's not that bad. 44:39. I am apparently really consistent at being just about 3 minutes past the part 2 leaderboard. That's 3 days in a row. That's impressive. Um, just out of curiosity, yeah. There's Jonathan, way faster than me. So let's talk about this problem. This is definitely a good callback to Intcode. If somebody is watching this, and I'll throw this out now. Frankly, I'm a little surprised anybody's watching these, but I've seen some people are. So, hi, welcome. Anyway, if any of you watching have not seen Intcode before, that is a callback to 2019, which was actually the first year I did this live. And Intcode was a theme throughout the entire event. It was actually a pretty fun theme, in my opinion. So you got these Intcode programs that then started on day 2, build up some opcodes, and then by the later in the year, we had some really fancy problems. Let's see. Actually, was this one of them? No. Actually, that may have been one of them. But yeah, like this whole problem, you got a crazy encode program that you had to run and uh, get your uh, get your puzzle out of it, getting the maze here, the scaffolding, and then operate on it. So I actually really enjoyed it. I know it was a very controversial year, but I liked Encode. I like the callback. Anyway, so with this callback, we have a much more simplified instruction set. The Encode VM was actually pretty feature rich. Given how simple it was, it did a lot. But here, this is just a mostly forward computation. We're not even messing with the encode program itself, or rather with the program itself, like you did in Intcode. All we have is these registers and some operations that then operate on those registers. So yeah, I mean part 1, it's mostly just read through these, painstakingly implement, all of the individual operations. I probably could have gone and written this quicker, but I was being careful. I would prefer to get it right than to rush and then spend forever debugging. I was actually a little worried when I first submitted an answer and it was wrong that I was going to spend forever debugging. Uh, my what was my bug? Um, yeah, was the BXL operator where I was doing or instead of exclusive or, which was kind of funny. I even went into a Python shell and just double checked that I was doing the bitwise or correctly, and that wasn't even what was asked for. Out of curiosity, without that particular bug, how fast would I have been? I had that bad answer submitted at 9:57. Ooh, I lost time. I lost like 4 minutes there. Eh, it's again a repeat of recent days where I've had a bug where I just lose just about the same amount of time that I would have needed to get the leaderboard. But yeah, part one is just implement this instruction set, run it through, take the output, and submit the output. Part two is what I was really scared of as I was writing part one, where, yeah, in part two, then you need to decompile it, which has been a theme amongst a number of the years. Interestingly, decompiling programs was not a part of 2019 in the Intcode year. There was one crazy person who went and decompiled all the Intcode programs in Excel because he wanted to solve them all in Excel, but this was not something that came up in 2019. So this was an interesting and scary twist because decompiling is always a bit tricky. My strategy, which you saw me employ here, is to take the program and zip through it and print it out into a nice and relatively simple human readable form. It took me actually a couple of tries to get this right because I kept forgetting to format the operand or the combo operand. But once I got that done, I had a much easier thing to look at and analyze and work through. Then, once we've got this dumped out, it's analyzation time, which there's not that much to say other than just do it. It took me a while to realize. A lot of times when we've done this analyzation, it's been you fully decompile and understand the entire program. That's the rut I was actually getting trapped in. As I was working here, I was trying to go, okay, from the output value, work backwards, then this is a direct computation. We can figure this out. This is tricky. What exactly would C be being exclusive ORed with the B? That comes then from the upper bits of A. We did a modulus A. It gets really complicated here. I spent way too long trying to reverse engineer this bit until I realized, wait a moment, we can actually just, because we're taking the bits out of A to then generate the output sequence, I don't actually need to fully understand this. I can just write a little program that goes through brute forces, really, the 8 different combinations of bits that can be in the lower bits of A, and just try them and see which ones are still succeeding in giving me the value that I want. Because all the previous outputs, all the previous digits, would have been the higher bits of A, and we're not going to be able to affect them anymore. Because fundamentally, what we're doing, and let me go back to the raw output here. Let me go back to the really raw output here. And let's just walk through the decompilation and understanding process. So the only go-to we have is going to label 0, and so we can ignore all the rest. And then from A, there's only really three things that are pulling from A. The first thing, we're taking the lower three bits. Then we're pulling some number of bits. This is actually a shift operator, just in disguise. And then we're shifting A down by 3 bits. So, given that, we'll output something, do some computation, get a B value, output it, and then operate on the next 3 bits from A, loop again, so on and so forth until A is empty and A runs out. So yeah, with that knowledge, it's actually relatively easy to just keep testing every single combination of bits, keep track of the ones that still work, and then dump them all out. I was actually a little worried. I have kind of lost. Yeah, here we go. I was worried that the number of accepted patterns was going to grow exponentially. I was really glad to see only only 5 possible values here. There is something weird going on in my reverse engineering code here, because 4 of these values don't even work. 4 of these values don't output the 0. I'm what I wonder actually, and we can test this pretty quickly. Except if that and new A is greater than 0. I wonder if the very first value that we're getting, or we're testing against, the new A just ends up 0 works. But the problem is we would stop iterating in this code. We would stop iterating whenever A hits 0. And so for the very first value we're trying to output, yeah, A just can't be 0. So I wonder if the 4 bad values are just that. So let's give that a try. And yeah, that's actually exactly what was happening. And then that's a little tricky of the problem text. It's saying, what is the lowest positive initial value for the register A? There is only one initial value for A. And that makes sense. Well, I guess technically there are an infinite number of initial values. Well, are there even? There's an infinite number of initial values of A that output the program at the beginning. If you keep adding bits over on the left side, you're actually going to just keep iterating in the overall loop and output even more numbers to the right. So yeah, I think this is guaranteed to be a unique answer, and I think all the programs are guaranteed to have one unique answer. Yeah, so that was definitely an interesting problem. I would have been faster if I had realized I could just do this only partial reverse engineering and then brute force the rest. But I got there eventually. The one thing that always I'm a little icky about with these reverse engineering problems is half of what I did here is not encoded in code. So I do like having all of my solutions be able to run from scratch with minimal external knowledge and just understanding of the internal program. It's going to be interesting to see how that can be done here. I'm sure it's possible, but I might actually need to see more inputs before I can even conceive of how to do that. But that is a problem for me to do some other time. So yeah, that does mean though I am down to eight more days to try and get on the leaderboard. And that does also mean actually 2019, as I said, was the first year I did this. And day 17 was the first day, and 2019 that I got leaderboard points. So I am actually now global leaderboard wise behind where I was in my first year. So that feels bad. I'll see if I can step up my game in the next 8 days. So yeah, that's about it from me for today.